Alright, so we are looking today at solving trig equations. The main thing to focus on here is this verb. So we had been verifying, and in our verifications, our proofs, we only worked on one side of the equals. Now we're solving trig equations, which means we're going to solve trig equations the same way we solve algebraic equations. We might add the same thing to both sides. We might multiply by both sides. We might factor. We might square. Okay? But the big picture is that we want to isolate the trig function. Right? Isolate. Get it by itself. Just like in algebra, how you get x on one side of the equals, we want to get our trig function to be on one side of the equals. And if we have more than one trig function, we want to get down to just one trig function. So like if we have sine and cosine, we want to get it to be just one or the other, and then we want to get that one by itself. Alright, when we're solving trig equations, there's also two types of answers, or two ways to answer. So one way is they could say, the instructions could say, please give all the answers on a certain interval. And typically that interval is from 0 to 2 pi. And the reason that that interval is usually that is because that's a period length for cosine, sine, secant, and cosecant. Now notice there's a bracket on the 0, so the 0 is included. And there's a parenthesis on the 2 pi, so the 2 pi is not included. Now, the other way you might give an answer is to give all solutions. And so we're going to do some problems, and we're going to give our answers in both ways. And then when you do work, you'll just want to follow the instructions. Sometimes it'll say on a certain interval, and sometimes it will say all solutions. Alright, so let's start with a fairly basic one. Let's say I have 2 sine theta minus 1 equals sine theta. So I'm trying to find the value of theta, right? But before I get theta by itself, I just want to think about getting the sine theta by itself. So in this case, I have sine theta on the left side of the equals. I have a sine theta over on the right-hand side of the equals. So my first strategy would be to subtract a sine theta from both sides of the equation. I can do this because these are, in fact, equal. So 2 sine theta minus sine theta is sine theta minus 1 equals 0. And then I'm going to add 1 to both sides. And sine of theta is equal to 1. And so then at this point, I refer to my unit circle. What value of theta do you need to have for the sine of theta to come out equal to 1? A 90-degree angle, but we're going to answer in radians, so 90 degrees is pi over 2. So theta is equal to pi over 2. Is that the only time in between 0 and 2 pi that the sine is 1? Yes, it is. So that's your answer for theta. If they ask you for the answer between 0 and 2 pi, that's your one and only answer. Now, if they ask you for all solutions, then you're going to have theta is equal to pi over 2. But then, every time you take a lap around that unit circle, you're going to get back to 1, right? So let me just pull up a little graph here, back from when we were graphing. All right. So just look at this part. Here is 1 period of sine. So my sine of theta is 1 right there at pi over 2. But if I look at my entire domain, negative infinity to infinity, the sine is 1, and then the sine is 1 again, and then the sine is 1 again, right? We're going to have an infinite number of times that the sine is 1. It's going to happen every 2 pi units. So if it asks for all solutions, it's going to be pi over 2 plus 2 pi n. So when it says all, that's going to be your answer. So all we're doing is the same types of steps we do to solve an equation in algebra. We get down to our trig being isolated. We use our unit circle to get the answer. If we're on 0 to 2 pi, we're just going to have 1 or 2 answers. If it's all, then we're going to add the plus, the period, to get all those answers. All right. But sometimes it's not as simple as that one. So example 2 that I'm going to give you is going to use a strategy. The strategy that I'm going to use here is going to be to square both sides. Now, you're not going to square both sides on every problem. We didn't square both sides in the problem we just finished. This is a strategy that you use sometimes, right? So this problem says cosecant x minus cotangent of x is equal to 1. And again, what we're doing today is solving. We're solving for x. We're not trying to prove this. So first of all, I have a cosecant, I have a cotangent, and right now they're both on the same side of the equals. So I want to isolate one. So I'm going to get the cosecant to be by itself. So I'm going to add a cotangent x to both sides. And here I'm going to get cosecant x equals 1 plus cotangent of x. And at this point, I might be kind of stumped. Like, cosecant, cotangent, what am I going to do? When you kind of hit that roadblock, well, what if we square both sides? So I'm going to come here, put this entire side in parentheses and square it. Put the other side in parentheses and square it. Alright, so cosecant of x times cosecant of x, we write that as cosecant squared of x. Right? We're not squaring our x, we're squaring our cosecant. And 1 plus cotangent x squared means to multiply 1 plus cotangent x times 1 plus cotangent x. It does not mean to distribute this exponent over addition. That's just wrong math. You can't do that. All right, so on my right-hand side, I'm going to go ahead and multiply by distributing. 1 times 1 is 1. 1 times cotangent is cotangent, and cotangent times 1 is cotangent, so that's 2 cotangent x. And then cotangent times cotangent is cotangent squared x. This looks like I'm making a bigger mess than even what I started with. And then over on this other side, cosecant. Now I've got two trig functions. Cosecant is squared, cotangent is squared. Then I've got a cotangent here. I'm going to have to do a substitution off of my chart because this is too many different things in here. So look on your yellow chart and find cosecant squared x. Or cosecant squared theta. You see this on your yellow chart under Pythagorean identity on the far right side? Cotangent squared theta plus 1 equals cosecant squared theta. So we're going to do this substitution. So instead of cosecant squared theta, I'm going to put cotangent squared theta plus 1. All right, no more cosecant. Now, this is an equation. I know they are equal, so I can add and subtract things from both sides. So I see both sides have a cotangent squared. I'm going to subtract that from both sides. Oh, I'm mixing up x's and thetas. Let me fix that. Make everything be x's. And I see this side has a plus 1 and this side has a 1. I'm going to subtract those also in the same step. So now my left-hand side is just 0. Right? I subtracted everything I had away. And my right-hand side is now 2 times cotangent of x. I want to get this trig function by itself, so I'm going to divide both sides by 2. 0 divided by 2 is 0. All right, so now I'm just looking on my unit circle. When is the cotangent going to be 0? Now, if you took your video notes and you have that little table, that can be very helpful for these problems. Or you can also look at your unit circle. Cotangent is cosine over sine. So cotangent is 0 whenever cosine is 0. So if the cotangent of x is 0, what does x have to equal? Pi over 2. Or 3 pi over 2. And if they just ask you for the answers on the interval 0 to 2 pi, that's your answer. Now, what if they said all solutions? All right, let's look at our unit circle, what's happening here. Pi over 2, and again at 3 pi over 2, right? And every time you go around, you're going to hit an answer. So what's this distance from here to here? Pi. So couldn't I say x is equal to pi over 2 plus pi n here? And then add pi, I'm at 3 pi over 2. And add another pi, and another pi, and another pi, and another pi. And that's going to get me all my answers. Make sense? Alright. Sometimes squaring is not what you want to do. Sometimes the strategy that you want to use is to factor. Alright, so our next equation is cosine x sine x equals 3 cosine x. Now, if you're looking at this and you might say, well, there's cosine x times sine x, and there's 3 times cosine x, and so a way to undo multiplication is to do division, so maybe we should divide by cosine x. And I'd be following right along with you, and it seems to make sense, but you can't do it. Alright, so let's just put a little note over here. Do not divide by cosine x.
Does that go for any trig function or only cosine?
Well, we're going to talk about why, and then you'll be able to answer that question. Why am I saying we can't divide by cosine x? Well, what's the number that we can't divide by?
0.
0. So here's the thing. Does cosine x equal 0 sometimes? Right? Cosine x can equal 0. So the reason we can't divide by cosine x is because if you do, then you're dividing by 0, at least for certain values. And division by 0 is undefined. So any trig function that sometimes has a value of 0, you can't divide by that. Does that make sense? Alright, so that's what we can't do. So let's just get all the trig functions on one side. So I'm going to subtract 3 cosine x from both sides. So my left-hand side is going to say cosine x sine x minus 3 cosine x equals 0. And now I have a common factor. Right? There's a cosine x factor in my first term, and there's a cosine x factor in my second term, and so I'm going to factor out the common factor. Factor out cosine x. Oftentimes when it looks like you want to do division, factoring that thing that you thought you could divide is what's going to be in its place. So if I factor out the cosine x, I have cosine x times sine x minus 3. And that is equal to 0. And now that is beautiful. The reason it's beautiful is because now I have 2 factors being equal to 0. If I do multiplication and my product comes out to be 0, then it absolutely has to be true that one of my factors is 0. Right? If I have subtraction or addition, these things could be anything, right? It could be 5 minus 5, 2 minus 2, 117 minus 117, right? But if I have something times something equals 0, one of the 2 somethings has to be 0. The only way you get 0 for an answer of multiplying is if one of your 2 factors is 0. So you just say cosine x equals 0 or sine x minus 3 equals 0. So you did this back in Algebra 2 when you were factoring quadratics, and then you set the product equal to 0. All right, so when is the cosine of x equal to 0?
90 degrees or pi over 2.
Pi over 2 and 3 pi over 2. All right, now, over on this equation, I would add 3 to both sides. So when is sine of x equal to 3? It isn't. You remember your graph for sine? The range for sine goes from -1 to +1. When is sine going to be 3? Never. So this part has no solution. So it's only that answer right there. Pi over 2 or 3 pi over 2.
Is there a difference between undefined and no solution?
Yes.
Okay.
Now, these are my specific answers in the interval 0 to 2 pi. If I wanted all of my solutions, the most succinct way to write this would be x equals pi over 2 plus pi n. Right? Because if you go around pi, you'll be at 3 pi over 2. So if you were taking a multiple choice test, I would expect this to be your answer. I just want to say that another way that would be correct, if you said x equals pi over 2 plus 2 pi n, and x equals 3 pi over 2 plus 2 pi n. So what you're saying here is you're saying, here's an answer, and then every time I go around the circle, I'm landing on that answer again. And here's another answer, and every time I go around the circle, I'm landing on that answer again. Right? Because all the way around the circle is 2 pi. But because these 2 points are half a circle away, this is like a condensed way to take these 2 answers and combine them into one statement. But your work for me, if you put this, that would be just as good. I know that you're understanding that it's at pi over 2 and then every cycle. All right. So notice, all 3 of these equations, we were solving equations, adding things to both sides, subtracting from both sides. But then depending on the type of equation, we might pull factoring in as a strategy. We might pull squaring in as a strategy. We might pull a square root in as a strategy. Let's look at that one really quickly. Let's suppose I had one, let me just say, cosine squared theta equals 1. What are you going to do with that guy? Yeah, you want to get rid of this square, so you're going to do the square root of both sides, but here's the caution. When you do this square root, what needs to go in front of it? Plus or minus. So the square root and the square undo each other, and so cosine of theta equals plus or minus 1. So when is the cosine of theta 1?
0.
At 0. And when is the cosine of theta negative 1?
Pi.
At pi. So if you forget to put the plus or minus, you might only get half the right answer. So that's kind of like a big reminder. There's that. When you do that square root, remember that plus or minus.